all my gang members. I'm really sorry for not being present for the past year. But as we say that stuff goes on. Today I'm back here again to teach you a very interesting concept. For the first time we are just not going to do a lecture, but we are also going to perform an experiment. This is a very important chapter for TDSB syllabus grade 10, and that is mirrors. There are two types of mirrors. One is concave mirror and one is convex mirror. Today we will only focus on the image and the reflection of light on a concave mirror. First of all, let us understand what we mean by a concave mirror. Concave mirror is an imaginary mirror, this curved inside out. So you can see that the reflected part here, this blue color, is just the shaded part. The reflection occurs in the inside of this curvature mirror. If you can imagine this circle, if you can imagine here this C shape and try to imagine a sphere, you will find that this sphere has a center part, and that center part, C in our case, is known as center of curvature. Then comes another part that's known as a focus. Focus is exact the middle point between center of curvature and vertex. So you will find that this is known as center of curvature. The middle point between center of curvature and vertex is focus. And here in the end we call it vertex. Vertex is the middle point of the entire curved mirror. When a line strikes this mirror, well, if it was a plain mirror, the line would have exited the way it had entered. So the angle of incidence would be equal to angle of reflection. But that's not the case in the curved mirror. We will step by step we will understand that how light behaves when it hits the surface of the curved mirror. First you can see number 1. This is a parallel line that hits the mirror. When a parallel line hits the curved mirror, it passes through the focus. I'll repeat once again. When a parallel line hits the mirror, it will pass through focus. So it's easy to say that when a light passes through a focus, it will hit parallel to the mirror. So you can see line number 1 and line number 2 are kind of like similar to each other. Then third phenomenon of light is when light will hit through the center of curvature. If light bounces or light passes through center of curvature, it will bounce back at the same path. So you can see the light will not change its path at all. And finally, our point is when a light hits directly to the vertex, it will pass with the same path on the other side. If you can think carefully, this center point X is the same point as it would be on a mirror. Here the curvature would be 0. So only and only this point will work as a middle point. So the angle here, you can see angle of incidence is equal to angle of reflection. So this is it with the theory, and now we'll quickly switch on to the real experiment. We will see here that what happens and how image is formed. So in our experiment we will put the object on certain distances away from the mirror. First, as usual, we'll put an object very far away, parallel. So as you can see in the diagram, you should see that if an object is very far away, you will just see a dot point at the focus. Then we will try to put it somewhere just a little bit ahead of center of curvature. Then we will try to put it on center of curvature, then between these 2 points, center of curvature and focus, then finally at focus, and finally between focus and vertex. At different distance we will see how light produces an image. So without wasting any time, let's come back to the experiment. Thank you. Okay, so here we have a concave mirror in front of you. This mirror is a concave mirror, And as you can see that I figure out its focus point is 20, and so if this is the focus point, so its center of curvature is this 40 centimeter long. As you can see, this is 20 and its center of curvature C is 40 centimeter long. And then I just put a point beyond C, that is point O here. One more time, this is my mirror, this is its focus point, that is this the distance between the center of curvature and my vertex and my focus. The distance between the vertex and my focus is 20 centimeter, and the distance between focus and my center of curvature is another 20 centimeter. The total radius is a 40 centimeter of this mirror. Now if we first, I will show you if the object is as parallel beyond the, if object is very far away, means it is at parallel. So if the object is at parallel, you will find a very thin amount of light at the focus. You will find a dot forming at the focus. So in this particular case, first I'll put my object at center of curvature. Now according to the diagram, if I put my object exactly at center of curvature, I should get a total inverted image at the bottom, which would be a real image, and it would be as the same size of the object. Due to the limitations of my experiment, I would be able to show you a little bit of the formation. A little bit, you can see a shadow image forming at the back. You will get a perfect image of this object, of the light underneath it. Then this is at the focus. When this is at the focus, you will see that the light reflects and you can form an image at infinity. It is a very highly enlarged image, and you can see that the light is following its path all the way back here. That shows that the light is following till infinity. So there are various distances where we can put an object and find the image, and today I would only show you one part where the object is placed between the focus and the vertex. If you see the object is between focus and vertex, you will get a highly enlarged image, which is a virtual image at the behind the mirror. And this is an erect, it replicates the same image that is here. As you can see, it replicates the same image of that of the object, but it is it is highly enlarged, 2 or 3 times magnified than the object. This is a wonderful experiment showing that when you place an object at different distance, it will reflect at different way. So gang members, if you try this experiment at your home, you will be able to see different images at different distance from the mirror. Well, due to our limitations with camera and our place, I was only able to show you one image, which is when the object is between focus and the center of curvature. But I hope this was helpful to you, and I hope to see you all again soon. Till then, take care, goodbye. Hi gang members, first of all I would like to thank my students Jinal, Jia and Kavya, and this video is special to me because they were present there physically to help me to make this video, and I cannot imagine making all this series without them. And yeah, most importantly, don't forget to watch the bloopers after this. I hope you learned something from it. I hope you enjoyed the video. Thank you. Done, Jinal?
Hey, it's fine. It's good experiment. Good, continue. 3.
I hope this was helpful, and we'll see you again soon. Thank you. It gets the same image of the object, but it is. So guys, I hope with all the limitation I was able to underneath it. Okay. At this part. Then this thing is at the all the way back here.
Sir, it's not. It just looks like
Yeah, you can't see.
Huh?
There should be. I don't. Okay, hold on.
Oh, okay. Yeah.
Turn the light on for a second. Look.
I don't know if there's paper, but look where the orange bag is. Check that. different that paper, right? White paper. Underneath, is it underneath or on top? That's not exactly. No, like a white paper. White paper? Like a...
Rise and shine.